Welcome to AI Frontiers, your trusted guide to the latest breakthroughs shaping the trajectory of artificial intelligence. This episode is titled, Seeing Beyond Pixels: The State of Computer Vision, with the subtitle, Synthesizing 64 Papers published on May 25, 2025. In this episode, listeners will embark on a comprehensive exploration of the newest developments in computer vision, a field that remains central to the evolution of intelligent systems. Drawing from a curated collection of 64 research papers published on May 25, 2025, this narrative is designed for AI practitioners, students, and anyone fascinated by how computers are learning to perceive and interpret the world. Key highlights include a deep dive into the latest research, identification of major trends and technical breakthroughs, and a journey through the interplay of vision, language, and real-world impact. The goal is to provide not just a summary, but a nuanced, spoken-word optimized synthesis that connects advances across the entire landscape of computer vision. Whether you are looking to understand key technical methods or the broader societal implications, this episode serves as your entry point into the rapidly advancing world of machine perception. In this segment, listeners can expect to connect the dots across multiple dimensions of computer vision research. The discussion will explore the dominant themes and innovations revealed by the latest body of work, delving into technical advances in generative modeling and the fusion of vision and language modalities. The episode will spotlight 3 influential papers that are actively shaping the direction of the field. In addition, the narrative will address critical challenges, future research directions, and the societal implications that accompany these technical developments. By the end of this episode, listeners will be equipped with actionable insights and a holistic view of the progress in computer vision, positioning themselves at the forefront of the next wave of AI advancements. Computer vision stands as the eyes of artificial intelligence, focusing on enabling machines to interpret, process, and understand visual information from the surrounding world. This scientific discipline powers a vast array of applications, ranging from medical imaging and disease detection to autonomous vehicles and industrial automation. By sitting at the intersection of artificial intelligence, machine learning, signal processing, and computer graphics, computer vision is essential for enabling navigation, recognition, and reasoning in intelligent systems. Its foundational role has driven the demand for robust, scalable, and generalizable algorithms capable of handling the ever-increasing volume and complexity of image and video data. As devices equipped with cameras and sensors proliferate, the significance of computer vision continues to grow, cementing its place at the heart of modern AI. The first major theme emerging from current research is the advancement of generative models and image synthesis techniques. This area focuses on systems capable of not only analyzing but also creating and editing images based on textual or visual prompts. Noteworthy contributions include the method by Chenrui Ma and colleagues, which enables fine-grained, instruction-driven image editing without the need for labor-intensive editing pair datasets. Additionally, the Alchemist paradigm transforms public text-to-image data into valuable resources for generative tasks. These innovations empower users to specify detailed and nuanced changes to images through natural language, significantly improving the fidelity, controllability, and efficiency of image generation. Such advances are rapidly expanding the possibilities for both creative and practical applications in fields ranging from content creation to digital design. A second prominent theme centers on the transformative impact of computer vision in medical image analysis and healthcare. Recent research underscores the role of AI in enhancing diagnostics and streamlining medical workflows. For example, Chang Hu and colleagues present a novel alignment-free approach to polyp classification in colonoscopy, which improves diagnostic accuracy without requiring precise lesion localization. Across the broader literature, advances are being made in segmentation, restoration, and robust disease detection, particularly in resource-constrained settings where advanced imaging technology may not always be available. These developments collectively drive greater accessibility and accuracy in healthcare delivery, making sophisticated medical diagnostics more widely attainable and reliable. The third theme highlights the integration of visual and linguistic data, often referred to as multimodal learning and vision-language fusion. This approach enables deeper understanding by combining the strengths of visual perception and language comprehension. Research efforts such as MindEdit and SegVLM have demonstrated how combining image and text modalities can facilitate tasks like image editing and segmentation. These models allow for more natural, instruction-based interaction with AI systems, improving capabilities in tasks such as question answering and content creation. The fusion of vision and language is seen as a key enabler for human-computer collaboration, accessibility, and the development of AI systems that can interpret and respond to complex, real-world scenarios. Theme 4 addresses significant advances in scene understanding, three-dimensional reconstruction, and real-time capabilities. Central to this progress are methods for reconstructing and rendering complex environments with high speed and visual fidelity. Jan Held and colleagues introduced triangle splatting for real-time radiance field rendering, a technique that revives mesh-based graphics for rapid neural rendering. The VPGS SLAM framework demonstrates scalable three-dimensional mapping in large-scale environments, supporting robust navigation and localization. In the medical domain, polyp offers a solution for localizing deformable anatomy in 3 dimensions from sparse 2-dimensional X-ray images using polyrigid transforms. Collectively, these advances emphasize the importance of speed, accuracy, and practical deployment in modern computer vision applications, from robotics to immersive media. Several key breakthroughs and their broader implications are highlighted in this section. Instruction-driven image editing, as pioneered by Chenrui Ma and colleagues, removes the traditional bottleneck of requiring large editing pair datasets, thus democratizing access to advanced editing technologies. The triangle splatting technique by Jan Held's team revives and modernizes mesh-based rendering, achieving unprecedented speed and visual quality. Dense knowledge distillation, as implemented by Chang Hu et al., enables improved medical diagnostics without the need for precise annotation or alignment, making AI-based healthcare more practical and accessible. The rising capabilities of vision language models introduce new privacy and ethical considerations, especially as these systems become capable of inferring sensitive information from personal images. Finally, the development of accelerated, robust, and resource-efficient models is enabling the deployment of computer vision across a broader spectrum of real-world applications. Methodological innovations underpinning these advances are numerous and diverse. Diffusion models have gained prominence for their ability to transform random noise into high-fidelity images through learned denoising processes. Vision-language fusion techniques align and integrate semantic and visual features, enabling models to better understand and generate content that combines both modalities. Reinforcement learning is increasingly applied to optimize layouts and guide generative models towards human-aligned outcomes, particularly in complex or multi-stage tasks. Knowledge distillation remains crucial for transferring expertise from large, high-capacity models to smaller, more efficient ones, thus facilitating deployment on resource-constrained devices. Splatting and three-dimensional representation learning techniques have made high-fidelity, efficient scene reconstruction possible, further expanding the reach of computer vision technologies into new domains. The first spotlighted paper, authored by Chenrui Ma and collaborators, addresses the challenge of text-driven image editing by removing the need for labor-intensive editing pair datasets. Their approach utilizes multi-scale learnable regions, which allow for precise and instruction-consistent edits without reliance on explicit before and after image pairs. The method adapts seamlessly to various generative models and supports a wide array of editing tasks. Empirical evaluations demonstrate state-of-the-art performance in both fidelity and controllability, with the model delivering edits that closely align with user instructions. The impact of this work is substantial, as it broadens access to advanced image editing technology, reduces the barriers to model development, and enhances the naturalness and flexibility of the editing process. This innovation is poised to benefit creative industries, content moderation, and applications requiring dynamic visual modifications. The second spotlighted paper, presented by Chang Hu and colleagues, introduces a dense, alignment-free knowledge distillation framework for medical image analysis, particularly in colonoscopy. By bypassing the need for precise lesion localization or alignment, their method leverages pixel-wise cross-domain affinities to transfer diagnostic knowledge between imaging modes. Class activation mapping is employed to focus the distillation process on diagnostically relevant regions, ensuring that critical features are captured. This approach outperforms previous methods in both accuracy and robustness, as demonstrated across public and proprietary datasets. The practical significance of this work lies in its capacity to deliver advanced, accessible AI-driven diagnostics in real-world healthcare environments, especially where resources or expert annotations are limited. The third spotlighted paper, authored by Jan Held and collaborators, revisits triangle-based rendering by introducing differentiable splatting techniques. This approach achieves high visual fidelity and real-time performance, surpassing two-dimensional and three-dimensional Gaussian splatting methods, with rendering speeds exceeding 2,400 frames per second. The method maintains compatibility with existing graphics hardware and pipelines, facilitating rapid industry adoption. By bridging classical computer graphics and contemporary neural rendering, this innovation demonstrates that triangle-based representations can deliver both efficiency and superior perceptual quality. The implications extend across gaming, virtual reality, simulation, and digital twin technologies, marking a significant advancement in real-time scene rendering. Looking ahead, several challenges and promising directions are apparent in the field of computer vision. Data efficiency and model generalization continue to be key hurdles, as large-scale annotated datasets remain costly and models often struggle with rare events or out-of-distribution scenarios. The development of interpretable, fair, and privacy-preserving models is increasingly essential to ensure ethical and trustworthy deployment. Hybrid methods that blend classical graphics techniques with modern AI approaches are gaining traction, offering new pathways for innovation. Unified models capable of handling multiple modalities and domains are on the horizon, promising greater adaptability and general-purpose capabilities. Finally, the societal impact of these technologies underscores the importance of interdisciplinary collaboration, involving ethicists, domain experts, and end users in shaping the future of AI. This episode's content was synthesized using GPT-4.1 from OpenAI, which provided the narrative structure and analytical synthesis of the research literature. Text-to-speech narration was generated using Google Tools, while visual concepts were developed with the assistance of Grok. A human expert reviewed the final synthesis to ensure accuracy and clarity. While every effort has been made to deliver a comprehensive and precise account, listeners are encouraged to refer to the provided paper references for further details or to address potential oversights. AI Frontiers maintains a commitment to transparency and responsible AI storytelling, ensuring that each episode reflects the highest standards of technical rigor and ethical communication. Thank you for joining AI Frontiers as we explored the latest advances in computer vision research. To stay updated on new developments in AI, computer vision, and related domains, subscribe to the AI Frontiers YouTube channel for regular research deep dives. Engage with a global community of AI enthusiasts and experts, and access references and detailed episode notes in the video description. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, complex research is simplified so listeners can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server.